to get to the, as we like to say in Molière's finest language, pièce de résistance. Is that how it goes? Yeah? Yeah. I see some nods. We're ready to go. I mean, I'm just going to get to it. Ladies and gentlemen, for the last talk of the conference, please put your hands together for Alex Russell.
Thank you, Henry, and thank you to all the organizers. I think the whole 2 days have been just amazing. Can we just, yeah, for the organizers? I was saying to a few folks earlier that this is one of the few conferences I've been to where it is as daunting to imagine the audience as the fellow speakers. We were on the speaker boat earlier, the speaker dinner. It was on a boat, as you do in Amsterdam. And I was thinking to myself, just looking around, that if that sank, the web would get considerably slower. It just speaks to the quality of the content that we've had over the last couple of days and the dedication of everyone who's put this together, and the amazing data that's been shared has been truly eye-opening for me. And so instead of sharing truly eye-opening data that comes from deep research, I want to give you a pastiche, a guess, some big reckons, and I'm going to be honest about it because where I'm coming from with this is having a big question in the back of my mind across many years and making successive guesses, and hopefully they're okay. They've influenced a bunch of projects, and I feel some responsibility to trying to do an okay job at it. But I want to highlight the error bars because what I want to get to at the end of this is an introduction for how we can make guesses and forward progress in the midst of true uncertainty. Because when we're sitting in data and trying to make progress on web performance, it is often the case that we're just drowning in good information. We all have it in front of us. We can collect all these new stats, all these new metrics, but we kind of want to come up with a thesis or a theory and then go test it. And that's extremely difficult. It's a practice that we have to kind of develop. It did work. Amazing. So stepping back, web performance is about the web. A decade ago, this was Tim Berners-Lee at the opening ceremony of the 2012 Olympics, and he tweeted out, which I suppose that's aged poorly, that this is for everyone, referring to the World Wide Web. And that I think is not a dead letter. That is not a past-looking statement. That is something about where we are and where we should be going. That is a thing that we have to put into practice. It isn't a historical note about what the web was. Or it could be a historical note about the web was. That is under our control to some high degree. So folks have asked me over the years, what is web performance? Not why should I care, but like, what is it? And so this is the closest I've come to a concrete definition, which is that sort of taking on from Tim's idea that this is for everyone. Our job as folks who work in performance is to expand access to services and information by reducing latency and variance. And we don't want to do that just once. We want to do that for a whole session, right? But it's also important to understand that we're all connected. One of the interesting things about the world, for instance, of native applications is that they are silos. You go to a native application, you launch it from the home screen, you launch it from your task manager, and suddenly you are in a silo. And that silo never takes you outside the silo. And if it does, there's a big context switch that goes along with it. No two applications sort of interleave with each other. That just sort of doesn't happen. The experience of one doesn't affect the other. But on the web, the experience of one site or one application is commingled. You are part of a real live web. And the web is the set of links that are live today. That is what the web is. It's a set of links that you can resolve to. And so at every moment, the cumulative experience of the web reflects on you. We see this very directly. So if you just drill it all the way down to a trace, you'll see this in like an on-before-unload handler, right? Tapping on a link and it not loading quickly affects the next site. And so it is the cumulative experience of the web that makes the ecosystem valuable. We are all part of that ecosystem. We succeed or fail together. And so part of what we're doing is not just about ourselves. It is about our cumulative prospects in the future for having a web that we could want to build on and with. So to try to get to the bottom of, like, are we doing an okay job, over the last some years, call it 5 or 6 years, I put together a series of blog posts, and you could think of this talk as the next installment in that series. And if you've read any of my blog posts, the next question out of your lips is invariably going to be, how will he fit into an hour? And that's a good question. We'll try to get there. But it's come up with sort of rinky-dink little models like this. And in the spirit of all models are wrong, but some models are useful, the hope has been to try to come up with some understanding of the global factors that impact the addressable market for web content, because we all make web stuff, more or less, and then try to understand, in that world, what does it mean to do a baseline okay job in terms of content? Now, that has lots of factors that come into it. Those factors are very complex. And so we have to make guesses. And back in 2016, I gave a talk that pissed a lot of people off, I think it's fair to say, including some of my coworkers. And the goal of the talk wasn't to annoy anyone. It was instead to try to make a guess about what was reasonable at the time. And it put the finger squarely on JavaScript as being extremely expensive, and noted that things were going exactly the wrong direction at an ecosystem level. And this was informed by a lot of data, most of which I no longer have access to. But suffice to say, that was true. And so the guess at the time was maybe we should come up with, like, a vignette, a marginal user on a marginal device somewhere in the world that represents the marginal, the next person to come online in the next couple of years, and try to come up with an understanding of what they're going to be buying, what kind of networks they're going to be on, what kind of content they're going to be served. And with that in mind, we can start to calibrate where our baseline performance budgets should be. Because we can't really set budgets unless we know who our users are and what environment they're in. And so because mobile was starting to happen, for real and for serious, in 2016 we were just getting to the point where mobile was now, equivalent in traffic to desktop web traffic. It has now vastly surpassed it. And so the guess was, based on the available data, that we would be looking at a $300 to $350 device that was kind of mid-tier. It would be somewhere in the 28 nanometer Android environment, because that was what was selling at volume. 2 gigabytes of RAM. And I can't say enough bad things about the 28 nanometer process node. And the worst thing about it is that it has followed us like a stray dog for most of a decade. And at the time, it was already becoming super clear that we were going on an out, not up trajectory. That is to say, we would not get faster devices in aggregate every year. We would get a lot more of them with the exact same capabilities at a much lower price. Because what we were seeing was that smartphone penetration was starting to take hold. Now, remember that smartphones began in a world of really wealthy people. Like, I was in the room when Steve Jobs unveiled the iPhone, and I can tell you everyone else in that room made a lot of money, right? Just like as a basic world historical proposition, as a quintile statement about the wealth of the people in that room, top tier, right? So smartphones have been crawling down the wealth tier ever since, and that has meant that making them accessible means making them cheaper. And so this was unfortunately sadly prescient. It has been the case that the basic specifications on this phone, down to the CPU core design of this device, were effectively static for most of the outward spread of most computing devices in the world for the next decade. So 2017, updated with a blog post that sort of recapitulated the Moto G4 as a baseline. It's staying steady roughly in terms of capability, but at this point it had dropped, it's probably south of $250 at this point. And setting a target of 5 seconds to first load and 3 seconds on repeat load, ask the question, okay, what kind of budget can we actually set? If we want to hit those targets, what does the world look like such that we could try to get there? Okay, we've got our hardware, roughly. Okay, we've got our target for some interaction. We want it to take this long. What else do we need to know? We need to know something about networks, and we have to know something about content. And so, putting it all together, the estimate at the time was we could afford something, this is sort of pre-H2 everywhere, looking at the browsers at the time and the networks at the time, mostly 3G, because most of the world was connected over 3G in 2017. That may sound shocking to you because you were probably on 4G verging into LTE at the time. But most of the world was on 3G, and that meant that we could afford between 130 and 170K of content. Less if it happened to be mostly JavaScript. Okay, so updating this to 2021, there's another very long blog post, which I will save you the pain of reading. But suffice to say, Q1 last year, about March, we could think about the 75th percentile user as being someone who was sporting a phone that was 2-ish years old, maybe 3. And that meant that they were looking at this is actually a 2018 vintage phone, at about $150, because that's where the P75 was when it was sold. And it would be a 4-core, 1.4 gigahertz device with the exact same CPU core as we saw back in 2016. Literally the same CPU core. 4 of them, not 8 of them, but roughly the same amount of RAM. And the network got considerably better. So the big revolutionary thing between 2016 and 2021 was that 4G took over effectively the developing universe. As most new devices in the world were not replacements, but new sales, one of the big changes that occurred in the ecosystem was, for instance, in India, the storming of the market by Reliance Jio, which dropped the price of a packet in India by more than 85% in 6 months. That's an astonishing accomplishment, and it's fallen further even since. So that adds up to something like the ability to afford about 100 kilobytes of HTML and CSS. And then if you're still going to be piling into a big JavaScript payload, you could probably add another 300 to 350 kilobytes of JavaScript onto it. Lots of things have improved to make this livable on a device which is effectively static from the one that we were looking at before. It's a little bit faster per core because the clocks have fallen, because the process nodes got a little bit better. They're down to 16 or 11 nanometers in this case. But it's exactly the same, no cache, terrible in-order CPU instruction set running a slightly newer version of Android. That's big news, and that is enabled by better networks. Okay, now we're at the limiting factor, which is the CPU. And so it's important to understand the trajectory of CPUs in our environment because they now have a big impact, especially given the way the content is being developed. So to figure out what our global baseline should be, like what would we target if we didn't know anything about our own specific users and our own specific site and our own geo and our own market positioning and our own strategy, we will have to put some work into making an informed guess. And so this talk is designed to show you some of this work so that you can do the same kind of guessing for yourself and be just as wrong as I am, but in a slightly different way. Okay, so there's legs of the stool. We've talked about them already: browsers, networks, devices, and content. We sort of have to characterize all of them in order to put them into our formula to try to come up with some sort of reasonable baseline, that gives us a relatively conservative estimate for what we should try to target when we want to make something good for users at that margin. And I just can't stress this enough, right? We have to think about users at the margin because that's where markets are made. No one who's willing to buy or sell a stock at the price that it is not being offered on the open market is going to change the price of the stock. Markets are made at the margin. So understanding who the marginal user is how you make your next sale. It is how you address the next part of your larger market. Selling better into your existing users can happen, it can help, but it's often expanding your addressable market that matters. And those 4 factors already present a complex system. Right? If you just served effectively about blank over a mobile network to a mobile phone, or even over a cable modem to a wired device, you're already talking about hardware you don't control, running software you don't own, in an environment that you have no say over, to transversing networks that you have no control over and can barely quantify. right? This is a complex system, and complex systems mostly operate in partial failure most of the time. So we should be thinking about our systems as being subject to this partial failure at most points, and how do we try to cope with that? We've got lots of strategies. Some of them work better than others. Okay, so let's talk about the browser part of this. The important factors for us to understand when we're talking about browsers are diffusion and retirement rates. How fast do new browsers get into the ecosystem from the old version? And that can be through new hardware, through new operating system updates, that can be through in-place updates. That's your diffusion rate. How fast does it take for something to show up? And then there's the retirement rate, which is extremely related to the diffusion rate. So how quickly do 90, 95, 99% of a particular version of a browser go out of service to be replaced by a new version, or to be replaced by another browser, right? And we can get that data from Stat Counter. We can get it from our own private measurement data. That data tends to be pretty well quantified. You will probably have quibbles between your own data and publicly available data sets. They might be measured in different ways. One of the other big sites that published this kind of data for a bunch of years would use CIA factbook data for world internet population users to rebalance their own metrics, leading to hilariously wrong conclusions for something like a decade. So it's really important to understand the differences between your own data and what you're getting and the public data, and try to be thinking about where you might be seeing sources of error. We care a lot about protocol support. We care a lot about the available codecs. That has a big impact on our ability to get more punch out of the exact same content year over year. And you know this, we all know this, there will be bugs. And diffusion and retirement rates have a big impact on our ability to make future forward progress, because we're always going to polyfill the future, or we're going to polyfill the past. And the choice about which we're going to do often comes down to a question about how optimistic we can be about replacement rates. So we want to augur for a world where we understand our browser universe well enough to be able to predict the texture of it in the next couple of years. Okay, so networks are also extremely complicated. There's lots of data. A lot of it is conflicting. We can look at OpenSignal. They do tremendous analysis every year. But they don't publish anything other than medians. It's really hard to get a sense for the texture of the data. Speedtest will publish some observed data, but that's only for users who are like running a test from them specifically. The GSMA, which is an industry association for telcos, publishes often dated and largely inaccurate data, but it is at least directionally influential. And then you might have private data as well. We also care a lot about hardware support, right? The idea that a 5G network was rolled out in some geography has very little purchase on whether or not 5G is going to be used by the majority of devices in the environment, right? Like someone upgrading their network to DOCSIS 2.1. If the modems don't upgrade, no one gets a faster connection, right? So this matters a lot. And we have to be extremely focused on variance when it comes to networks. I think Ilya Grigorik once said that every 4G user is a 3G user sometimes. And every 5G user is a 4G user most of the time today. And sometimes a 3G user. And that variance means that when we look at P75, or we look past P75 to P90, P95, P99, what we're talking about are the same users, potentially, across a session in which lots of factors are moving underneath them. If you're on a moving device, a train, in a car, and you're moving between cells, handoff isn't cheap or free. You may be moving to areas of different density, right? With different allocations in terms of bandwidth and spectrum. And so all of these factors have a huge impact, and they create tons and tons and tons of variance. We have to be sensitive to that. We can't say, oh, it's an X kind of network, therefore it's this fast. Okay, so to get a sense of how variable this stuff is, at the bottom, here's some data from the United States, from OpenSignal, about what they consider to be excellent, consistent quality. And at the top is from India. You can see that these numbers vary wildly. But if we actually sort of put them on a 100% scale, we can see that geography has a huge impact. It isn't just our ability to understand whether or not something is going to go well or poorly on a particular carrier. We have to understand the general story in the places that we work, because otherwise none of this is really going to make sense when we try to tussle it out of our own performance metrics through a run provider. And the idea that some geography has some particular flavor, may or may not have a lot of purchase on whether or not this is going to work well for the majority of your users, right? Like the United States, where I'm from, sorry, it's not my fault, is extremely rural. That's not a lot of the population, but those folks matter, right? And if they matter to you, and if they are part of your marginal user, you have to be thinking about them too. Okay, so how can we understand this? How can we try to like get a handle on this? Well, Speedtest has some data. Other people have some data, but like this gives you a tenor of it, right? So here, the median that they get for downlink megabits per second is 105 on a mobile device, but the mean is 124. So this is actually, they're pretty close. That's okay. That's pretty good, and they're high. The U.S., of course, is much more variable, but it has a much higher sigma. Right? The distance between the mean and the median is much larger. So the variance for those users that you would expect to see in that geography is shockingly large. And India has much lower variance, but significantly worse performance overall. So all of these factors should feed into whether or not we want to be optimistic or conservative about making an estimate with regards to any of the baseline numbers that we put into our performance budgets. Okay, and it has to be said that desktop is highly variable as well. I think it's easy to gloss over desktop. I think everyone has a brand new M1 MacBook connected over fast Wi-Fi to a fiber connection. And that is not true. Like, it's true by inspection, but it's also true by induction. If you just think about where the set of users are who have desktops and what the income quintiles look like for most Western developed economies, you can't sustain the idea that most people will make enough money to buy a computer this year and pay for internet service that's that expensive. It just doesn't work, right? That doesn't compute, at least not in the US, at least. And the Markup just published an incredible series outlining some of this. Again, this is very US-centric, so I apologize. But the TLDR is that you can, especially thanks to what you can refer to as digital redlining, which is a play forward of some of America's worst racist instincts with regards to wealth destruction of marginalized communities. You can see that people who are in these historically marginalized communities will pay the same amount for significantly worse service on average in many places in the US. So there are many other forms of this worldwide, but what you should take away from this is that a connection that looks like X can actually be Y, which is a fraction of X. And it is plain as day when the data is available that not everyone is well served. So we need to be thinking about setting our baseline budgets extremely conservatively, because the inability to project our own situation forward into the world and have it make sense based on the data that comes back is a mystery for us to help solve. It is a way for us as performance people to try to understand the world as it is rather than how we want it to be. Okay, that means that we have to favor conservative estimates when we are faced with questions about the data that we don't really understand very, very well. And there will be lots of these. Okay, so let's look at the device situation form factors. Market penetration of devices in general matters a lot, right? So we're talking a little bit about how mobile devices were sort of filtering into the ecosystem. We're still in a place where the last 100 million, 200 million flip phones in India, or feature phones, are being replaced with smartphones now. There will be 1 billion smartphones on the subcontinent sometime in the next 3 years, which is an astonishing amount. But what you should understand about that is that we are still at the bottom of this curve, where we aren't to the place where everyone has their second phone and they want an even better one because they have gotten to the point where they know that they really like it. A lot of folks are still in that position of having an old phone, getting a smartphone for the first time at some expense, and learning that it's valuable. So we're still in the diffusion phase, and understanding where we are in terms of total addressable market versus market penetration has some impact on what we should expect to happen next. How quickly are these devices retired? How quickly does a device go out of service has a big impact on the median age, or the P75 age, or the P90 age of the devices in our population. So if we think about how we made that estimate between 2017 and 2021, the 2021 estimate is based on a couple of different triangulations, looking at the median device in a year and projecting out its retirement rate. So halfway through the lifetime of a device sold at the median price, in the median life, you suddenly have the median device, right? And the P75 device is somewhat older again. We can look at sales. Sales information has a big impact on the future. We can look at the performance in the volume segments rather than the ones that are marketed most heavily. All the margins for most technology products are at the very high end, and that means that the things that get noise are not the volume products, but ground truth is defined by volume. We care a lot about radio modem generations, right? Again, if the hardware doesn't support something, you aren't going to get the benefit of that thing. And we care a lot about disk latency because disks are not free. Going to disk is not costless. So where are we at on mobile? I think this is worth talking about. Phones live today about 3 to 4 years on average worldwide. The device replacement rate will vary widely by geography. In some wealthy places, it can be as low as 2 years. But for most of the world, 3 to 4 years is a reasonable estimate. An average selling price is performance destiny. The average selling price of a device today defines what the population will look like 2 years from now, 3 years from now, when we're looking at our P50 and P75 populations. Because where that lands determines the capabilities of the total body. So today, the average selling price of a mobile device is less than $350 US new, unlocked. That won't be the carrier subsidized price, but this is what it will cost wholesale. In the Android world, it's less than $300. And in the premium segment, it has gone north of $700. It is climbing up steadily in both places, but significantly higher in the premium segments than in the medians for both of them, which means, for folks who have an intuitive grasp of this kind of thing, that we're going to see a pulling away at the top end of devices in terms of their capabilities versus the median segment. We should expect that to be true. And in desktop, the story is maybe confusing, but I think these factors tell us a lot about what we see in the data, which is that most devices live between 5 and 8 years. That's a long time. The P50, the median device, was sold in 2018, right? And the P70 device was sold in 2016. I try to remember, I can't remember what was happening in 2016. Time is a flat circle now. But that was a long time ago, right? Like, Skylake was the brand new hotness from Intel in 2016. It's been a minute. Like, Haswell was still on the market. We're talking 4 cores as the volume chip parts, not 4-core, 8-thread, 4-core. And from edge telemetry, from the data that we see today, about half of our users are on spinning Rust. They're still on platters with heads that move every time you try to get data from the disk, right? It's going to take somewhere between 17 and 30 milliseconds to do a seek, right, on one of those slower versions of that. And potentially they may be contending with AV to get there. Most of those devices are at or below 4 gigabytes of RAM. Core count has almost, in this area, now that we've multi-threaded the browser, which happened over the last decade, core count has a very direct relationship to performance, perceived and real performance on a lot of workloads. And so we're not at a place yet where 8 core is normal, like the way it is, for instance, in mobile. And so this has impacts. And so I can't say this enough. Being wealthy is not normal, right? Like, being wealthy is unusual. We should be extremely grateful to be here and be wealthy. If you're in this room, we are, right? World historically, we're wealthy. But being wealthy is not normal. And we have to factor that into the way we think about setting our performance budgets, because we are serving people who are not us. We work for businesses who are serving people who are not the decision makers in the business. We are, if we work in the public sector, serving everyone. And that means everyone. And being wealthy is not normal. So we can see this in the data, right? As mobile phones became less of a luxury good and more of a daily necessity, the cheapest version of those devices absolutely took over the market. For the last decade, it's been extremely rare for Apple to sell more than 15% of the total device shipments. They command absolute price premiums. They are the top-end devices, both in performance and in price. But they are, and use is much higher because those devices are connected to better networks. Their users are much more in tune with the value of technology. It's less painful for them to use the web, so they're overrepresented in a sample set from use. But Apple doesn't sell that much hardware compared to the total world. So as technology becomes for everyone, everyone is now our user base, potentially. And we see this, right? Even in the US. We're still getting to the point now, this is data from Pew from last year, saying that smartphone penetration for all the folks who have a phone is not yet to 100%. Right? We're still in that end of the diffusion phase. And so we should expect prices to increase. So average sales price, again, is performance destiny for the future. So it's a time machine. We can travel future into what our performance world is going to look like based on average selling price today. And we are still at a point today where there are people getting their first smartphone. Right? That's happening right now. Okay, the takeaway here is that your iPhone is not real life. Like from an engineering perspective, as you are building your next project, it is extremely important to understand that your M1 laptop or your i7 laptop or your iPhone, these are not real life. This is not how everyone lives. And that is an input into our decision making. So today's median phone is an Android connected to 4G. Now, there may be 5G coverage wherever that thing is, but at the P50, that device was sold before 5G modems were even part of the pricing structure of the P75 or P50 device. It was sold a year and a half ago, and it was sold at the local market average selling price. So that is to say, if you splashed 900 euro on an iPhone, and all the other options in the shop were 300 euro Androids, guess which one is your target user, right? Okay, so that's median, but P50 is a vanity metric. Like, P50 is for telling your boss that you did a good job. It's not actually about anything that matters to your users. And today's 75th percentile phone, again, which is not a hard target, but it's more representative, is an Android on 4G that was sold more than 2 years ago, right? So this was the device that was sold for that 300 euros 2 years ago, 2.5 years ago. And that has an extreme impact on how we understand the world, because what we're doing in terms of the content that we produce is not really comporting with that reality. This is the HTTP archive report of the amount of JavaScript being shipped over the wire. I had some hope back when I wrote the post in 2021 that it looked like we were kind of leveling off, and if we just stayed leveled off for another year or two, maybe we'd be okay. But the median now is above 400K of JavaScript on a mobile website. Like that's transfer. 400K of gzip JavaScript on the wire, right? Like, an image map is smaller. An image of every website that you go to, no matter how high density the screen, would be smaller than the JavaScript we send to all of those phones. Okay. Someone told me that I was going to be a downer in this talk. I thought I was going to be quite optimistic. Yeah, so it's not going well. I've got charts like this for days. Okay, so I've been doing these updates on the CPUs, because again, this is now down to the CPU stuff, right? The networks are getting okay, right? But we're sending a lot of stuff, so that's still a problem. We got to think about it. So this is the 2021 update. I've been charting these. Surma, a former colleague of mine, started charting these a long time ago, and I've been continuing the series. So these are the Geekbench for charts for multi-core that I was able to collect up until last year, looking backwards, to the last set of flagships at the two top lines. This is multi-core for iOS and Android ecosystem at the top, and then there is a 300 to change price point line in orange just below it, and at the bottom is the $100 to $150 price point. And the $300 to $150 area is where all the growth in smartphone sales over the last decade have been. To a first approximation, every new smartphone sold, out of 10, maybe -2, were in this price segment. And single core, similar story. And so what about 2022, right? What we saw in that data is a little bit shocking because we see a delamination, right? Everything started back in 2015 or so. Let me go back. In roughly the same place in terms of single core performance. This is, by the way, back when Apple was still buying designs roughly from ARM and roughly integrating a different graphics thing, but using other people to supply their chips. Everything pulled away after that. And so now we're in a place where every successive generation of iOS device is significantly faster than every successive generation of almost every Android. And at the bottom, we're stagnating significantly. Okay, so 2022, did it change? Well, I had some hope, right? Like, we're moving to smaller process nodes, and those smaller process nodes should let us scale. We should be able to go faster. And the answer is no. I had to move the time series to Geekbench 5 because there's no Geekbench 4 data for the new devices, so I had to retest everything. But this is the same story. This will all be in the same blog post that I'll put up that you won't read. But it tells the exact same narrative, which is that at the very bottom, things will get better. They will get incrementally better. But we're experiencing a widening gap between the wealthy and the less well-off in terms of our digital ecosystem. And as we build content for this reality, if we are not in tune with it and thinking about this as the world that we inhabit, we may find ourselves in a privilege bubble. And so it's hard to see a privilege bubble. Like, you live in it, everyone you talk to, maybe you talk to friends and family who don't, but your boss, everyone you're responsible to, your peers, everyone around you is carrying the same devices. They're talking on to you across the same networks. They have the same kinds of experiences. So maybe it can feel weird that our digital life is not real life, that it is not what our users experience. And so, thank goodness, I did a bunch of work in BigQuery to try to get a bunch of data, and I realized that all the good people at the Web Almanac for this year had already done it for me. So here we are. Here are some of their slides. What we're seeing is that this looks kind of okay, right? It looks like we're doing all right. Interaction to next paint, which I think is one of the most sensitive metrics. Between this and total blocking, time to first byte, these are probably the most predictive measures for a good user experience for users in any geography. It looks like all right. Like, we're, half of mobile experiences are okay, and the other ones are trending into an okay zone. And if we look at a place like North America, we see that we're getting to 50% here of passing good core web vitals overall, for most of the population of the continent. And in Europe, it's actually quite good, right? But what this tells us is wealthy places feel okay, right? Relatively wealthy places feel relatively okay. Now, a 50% pass rate, I never passed a class that I ever took with a 50% pass rate. I didn't pass many classes in college, but so I identify with this chart. But for as bad as it can be, this doesn't suggest to us that there's a huge disparity. But let's look at the Asia-Pacific region. Now, these are selected countries that have more than 10,000 origins in their data set, so it's not everybody. But we're starting to see a much wider spread. And some of the largest population centers are on the far right-hand side of that chart. And if we look at this in terms of INP in blue and pass rates in light blue, what we get is a very almost confused picture, right? Which is to say, it seems odd that Australia would have such good INP when the core vitals are generally not great. but it's down to time to first byte, right? That's just to say the pipes are so gosh darn long to get to most of the content that it means that we can't do a good job kind of no matter how fast the devices are. But it's a wealthy country, so INP is good because the devices are fast. What we're starting to get a sense of here is the texture of the world that we inhabit, where wealthy countries, if they're not on the back end of the earth, don't let any Aussies hear that I said that, can do okay if the content's relatively local, right? This explains the local feeling that you get when you are attached to a network there. Meanwhile, a good chunk of the world, especially as the GDP per capita goes down, experience significantly worse content experiences for roughly the same set of content, no matter what. It's not just geography. So where does this leave us all up? Like we can use all of these charts to kind of intuit an understanding of the world, its networks, its phones, the browsers that we've got. And I will posit today, the punchline is that in Q4 2022, we can consider the Samsung Galaxy A50 to be roughly our baseline. You probably don't have one of these, I'm guessing. It's a $200 USD device. Again, average selling prices still around $300 in Android land, just north of that, all up. But P75 is going to be south of that. It's got 8 cores. The good news is that it's a slightly smaller process node now. We're starting to scale a little bit in frequencies, so CPUs are getting a little bit faster. The bad news is that these devices are basically still taking the exact same generation -3 that ARM sells into the market, stamping them directly into silicon and adding no cache whatsoever, right? Your JavaScript is still going to suck on this thing. Just to break it all down. It's got 4 gigabytes of RAM, and it's attached to a 4G network. Now, that network varies dramatically in latency and speed. And that means that our content constraints are largely unchanged. CPUs are stagnant, and networks get better at the rate of aggregate investment in a geography. So that is to say, cell density and backhaul cause networks to get faster, and that is a function of functional competition, which many countries don't have. And 5G is not a thing, right? Like you may have 5G around here on your phone, but for the purposes of our conversation, that's not a thing. Okay, so you always want to be sending HTML and CSS. You never want to be sending JavaScript. If you can do the same job with HTML and CSS, it's much cheaper. Do that. And that means that we can bump up our budgets a little bit because the CPUs are scaling a little bit to something like 150K of HTML and CSS, and we can afford a little bit more JavaScript, 300 to 350K, to get to 5-second first load, interactive, and 3-second repeat view. This, of course, is heavily dependent on the number of connections you made. There's been so much good, detailed recommendations over the last couple of days. Harry's talk about moving all of your stuff to the first party is a pro move for ensuring that whatever budget you set is actually something that you can hit. And you probably want to start adding interaction next pane and time to first byte logging because they are extremely sensitive. They tell you a lot about how it's going to go for your users. Okay, so the TLDR here is that when digital is the default, slow is exclusionary. And that means something for your business. It means something for what you're trying to do. If you're not making something just for yourself, or you're not making something for a known set of users, this is the takeaway. Okay, actually I'm going to skip this. I will just say, there are people in the world who have taken the best tools available. They have packed their webs. They have made their chunks so many chunks. They have client-side rendered all their things, but they'll forget to gzip stuff. And they won't understand basically how the world that they're building things for is used. I had to split this waterfall into 2 for obvious reasons. This is a site that is designed to help people in need get the help they need. This is what modern front end is doing. I don't think it's reasonable to say that we should sort of eat our Wheaties and recycle our aluminum. Recycling is a con by the oil industry, right? Plastic recycling anyway. We shouldn't necessarily say that this is a personal choice that we all are potentially on the wrong side of. I don't believe in that there's pure personal responsibility here. But as an ethos, as a thing that we're trying to get to, we need to do better than this. We need to set a bar about our profession that suggests that when we fail users, we are failing, right? That it is not okay just to do well inside the privilege bubble. And I think it's really important for us to understand how these costs actually trickle down to the users, right? We can talk about the next evolution of how we're going to program something for our DX. If this is the UX, I don't care. You shouldn't either. It's clearly a failure. Okay, I'm out of time, but I want to give you a very quick view on how you can take this basic approach to setting budgets and move it to your own environment, because this global baseline is quite austere, right? I acknowledge that it sounds very hard to hit because the global baseline was probably not your own environment. So ask yourself, who is our marginal user, right? What is the margin that you actually have to address? Now, that will come from your own data, but there is a hysteresis effect that you can observe, right? Where if you make something so slow that most users bounce off of it, they may never return or they may not be able to use it. Your data will tell you that it's working well for the set of users that you've got, but until you make it faster, you'll never know that you're excluding anyone, right? Slow is exclusionary. Slow removes access from people. So to do applied guesstimation, we want to start with our global baseline. We want to be conservative because of hysteresis, and then we want to find our marginal user, and then we want to try to find that user in our own data. We want to go attempt to understand who the users are who are having a bad-ish time out at the trail ends of our distribution and figure out what it would mean to do a better job for them. What are their devices? What are their networks? What are their browsers? How can we understand their world? And how can we understand them in terms of their entire session and not just the page load? Because if you think about loading a page versus tapping on a SPA in-app navigation, what is the functional difference? In most cases, there isn't one, semantically speaking. They're basically the same thing. You can pop up a level and think about this. I've got a whole rant on a brewing blog post about this. But basically, think about sessions. Think about interactions per session and not about individual pages. And then start collecting stuff that helps you understand those users from that context. Connection type, effective downlink, hardware concurrency, and device memory. These will help you bucket your users into high, medium, and low so that you can try to come up with a first level approximation of how your users, relative to the global data, are related. Are your users wealthy? Are you selling Prada handbags? Are you selling alligator belts? I don't know. To rich people. Okay, maybe these things are going to look great. If you are, however, trying to serve everyone in the world, understanding where your users actually lie can be extremely impactful, and good browsers have this data available. Okay, backing up though, it's product clarity. It's understanding your own users in your own context that really allows you to set budgets for yourself. So we want to start from a global budget that's quite conservative and then evolve into a product level budget that is based on an understanding of our own goals. What are the key user journeys? Who are we trying to serve, and what is the set of flows that they need to do? Right? It's great. I see lots of teams that have a metric for this one action that they took this one time. But how does that measure to the other ones? If I improve one by moving time away from it, am I just sort of moving time like water so that the next one gets slower? Until you have a full user journey that you're actually putting on the bench, it's really hard to get a sense for how your change is really going to impact this. Okay. If you take nothing else away from this, and I realize that I am between you and beer, please remember that performance is the root, it's the heart of access. When we do a good job on performance, we don't just do a good job for the business, we actually make everybody else's business better too. We make everybody else's product, we make everybody else's public sector site, we make everybody else's informational access better because we live in an interconnected web. The web is unique because it doesn't mix apps together, right? We are all subject, we live by the link and we die by the link. And so when we do a good job, we ensure that everyone else can succeed too. And so thank you for your attention. Thank you so much for having me, and looking forward to talking with you afterwards.